And now for our next talk, Federico Paolinelli will give us recipes for reducing cognitive load, yet another idiomatic Go talk. Please welcome Federico Paolinelli.
Hello. Okay, it works. Buongiorno, good morning. Thanks for coming to this talk. Thanks for Develer for organizing yet another nice GoLab in presence. It's really nice to be here again. Today I'm going to describe what cognitive load is and give some tips to try to reduce it, to make our Go code base a bit more readable and understandable. I always tend to try to explain the reason why I submit a talk to a conference, and the reason of this talk comes from more or less a year ago, when I started contributing to MetalLB. Does anyone knows what MetalLB is? Has anyone used it? So basically, MetalLB is a load balancer implementation for Kubernetes clusters that are not running on cloud environments where the cloud provider gives you the load balancer to reach your application from outside. So if you are running a home cluster or if you are following a Kubernetes tutorial based on VMs, there are good chances that you're going to need something like this or something similar to this in order to access your application from outside of the cluster, to expose your application to the external world. So I started contributing to it. At some point, I was asked if I was interested to become a maintainer of the project. The project is a nicely sized project. So it's not too big, not too much. It's really easy to navigate around it. I said yes, and suddenly I was almost more or less left alone because the other maintainers had other duties. Their main interest was not MetalLB anymore, so I found myself being the only gatekeeper of all the contributions, and I counted them the other day, and I realized that they were quite a few since I started being the maintainer. So this talk is basically the collection of the repeating patterns that I found, repeating over and over, trying to suggest in order to make the code base a bit better. And also, shameless plug, if you are looking for a Go project to send some contributions to, it's Hacktoberfest time. Try to look over the issues and see if you find something that is interesting. I'm Federico. I live in Pisa, not far from here. I work for Red Hat now for a bit more than 3 years. And in the past few years, I contributed to a variety of Go-based projects, some for my work, some others in my spare time. Athens was the first one that I started contributing to, and many others. I'm on the network side of Kubernetes. I started as a network engineer, saying that I didn't know anything about networking. I still need to restart my router when something is not working. But things are a bit better now. My Twitter handle, my GitHub handle are all FedePaol. If you want to reach me out, to give feedback, to ask questions, whatever, feel free to reach me and I'll try to reply there. And let's start with the talk. So what is cognitive load? Cognitive load is a complex way to say, to declare that amount of effort, that fatigue, that extra energy that you need to put in place when you are trying to understand something. It's our fatigue, the energy required when we try to understand, in our case, our code base. It could be because you are jumping on a new code base. It could be because you're getting back to a code base that you wrote 2 years ago and you need to understand the behavior, or you need to correlate the expected behavior to what you are reading. That energy that you put in place is this load. And the same is for when you get a bug report, you look at the code, the code is describing a certain behavior, the bug is another behavior, and there is something that doesn't match, and you need to put, in this case, a lot of energy to understand and to match the behavior to the bug. and that you get that exciting feeling when everything fits together and you solve the enigma, but suddenly then another bug is in the queue and you have to fix another one. So sometimes the load is proportional to the complexity of the thing that the code is trying to do. Think about super optimized algorithms. Think about cryptography, for example. There are some cases where the extra effort is justified by the complexity, but some other times is not. This is a simple JavaScript function that prints out hello world, and this is the same function put through an obfuscator. And this is a clear case where the extra effort is not necessary. So again, the idea is that we can do something in order to have something that is understandable compared to something that requires a lot of energy to be understood. Rob Pike has this very nice talk about Go's superpower, which is not Go routines, which is not tooling, which is not the compilation speed. All of those are very nice features, but his point, and I totally agree with that, is the fact that the real reason why Go is so successful is its simplicity. It's simple, or relatively simple compared to other languages, to jump on a new code base and to find yourself the way through it. But he also says that simplicity is complicated. And I think that this relates also to the way we write our code. So code is written to be read. We need to make an extra effort, which is the complication, to have our code base more readable, more understandable. And that is the complication. The reward is that reduced energy, that reduced friction when we go to a code base and we need to understand it. So let's start with the real set of tips. But first, one last disclaimer, and then I'll start, I promise. Not everything is black and white. So there are always exceptions. All of these tips may not be applied in all the cases, so treat them like as they are, just tips. I try to collect many of them from authoritative sources which I respect and which I agree with. So again, in that case, blame them, not me. So the first one is more or less a general rule that will be recurrent in this talk, and it is the fact that the readability has two phases. Do you think that this function is readable? There are no hidden tricks here. This function is readable. It is just sum that is making the sum of two integers. But what if we are going to use it? Then it's really hard to understand what this other function does, because we don't know what this function with the first function is doing. So again, my point here is the fact that in order to reduce that friction, we should care not only about the side of the implementation, but also we should care about the consumers of our functions, of our packages, of our code. And this is something that is going to be recurrent in many of the items that I'm going to show you. So the first one is well known, I think. It is the line of sight, and here it is. So good idiomatic Go code has this leftmost happy path where the line the eye can follow this line and follow the regular flow without exceptions, without the return situations, the error situations, and then we have the nested one where you have the return conditions, the error handling, and this is something that is present in all the idiomatic Go code and makes our code a bit more understandable. So there are a few tips to be able to implement this. Try to reduce else's. Every time I see an else in some PR, I try to think about how to eliminate it. Return early, leverage returns in order to avoid these else's. Try to avoid extra nesting, so one if is enough. And leveraging functions, you can get rid of an extra level of nesting, and you can also be able to leverage returns to get rid of else's again. So this is the most common case where we are using it. Probably anyone has, or many of you has a shortcut in your IDE to do that. If error is not nil, then return error. But sometimes you can have more complex scenarios that can be reduced, again, prioritizing returns, handling errors, in order to have a code base that is a bit more, more straightforward. And every time I see extra else's, extra nesting, I stop and I try to suggest a way to untangle this extra nesting in a way that is more clear. So again, there is nothing bad in this version. The problem is that when you land on it and when you need to understand it, you spend less energy. And think about a whole day of work, and then you get to the evening, you get a bug report, you need to understand it, and one version requires a bit less energy, the other one requires a bit more. And if you still don't trust me, this is a real example that I took. I changed it a bit, but that came from a real piece of code that I was asked to review, and by hammering it a bit, so flipping errors, leveraging returns, removing else's, wrapping into a function, and then leveraging returns again, we get to this coming from this. So again, it's clear, or at least I hope it's clear, that this version is easier to follow, and line of sight is not just a nice exercise. Line of sight is a way to reduce this friction in order to have your code base more readable and more easy to navigate. There is a very nice blog post by Matt Ryer about this. He comes with a collection of tips. The gist is avoid nesting, try to reduce else's, try to leverage returns to exit early from the function, and that was it for the first item. Now, I would like to talk a bit about package names. So naming is hard, we all know that. And that also is true for package names. A Go package name has this heavy responsibility of needing to be concise, but also needing to be clear in what the package has to offer. But there is more. So if you move yourself on the calling side, on the code that is consuming your package, then you have an extra responsibility of the package, because the name of the object you are consuming, the name of the function that you are consuming, the package name is part of that name. And so you can have something like this, where you have a kitchen sink package called util, where you have all the functions. It's still, like, if you look at the calling side, you have this wasted opportunity, this wasted real screen state that could be leveraged in a better way. So a better alternative of this is something like this, where the package name lets me know that this package is about nodes, whatever they are. This was taken from the Kubernetes world, but it could be anything. And then on the calling side, we still have this node.copy, which still offer the same amount of information that the other version has, but it's not wasting any space. This comes from the official Go blog post, Go blog, and it's basically saying the same. There is no need for having kitchen sinks packages where you throw all the util functions regardless of their scope. It's totally fine to split that in different sub-packages, relatively small packages that offer and does one single thing. Yeah, so Now I would like to talk about errors. This is trivia time. Has anyone saw this? I'm getting old. So this was the guru meditation from Amiga times when you were playing Monkey Island for 5 hours and then you lost everything because of these errors. So let's talk about errors. A lot of people new to the language come and they want to handle a special error situation, and they do like this. And in Go, errors are types. So by doing this, you are giving away the fact that the error is a type. You get the string from it, and you handle the string. But there are better ways to do that. We used to do something like this, having instances of the errors and comparing that instance with the errors that we were trying to assert. And then there was another version which was having a particular type that was implementing the error interface, and we were asserting the fact that the particular error that we were getting was of that type. With Go 1.13, so there are not more excuses not to use this version, we get errors.is and, sorry, them. And now? Sorry. I'm going to throw this remote away. This is so embarrassing. And Chrome is loading now. Ma senti, guarda, secondo me, se vai a vedere ci dovremmo riessere. Non vede niente. Ah, la rovescia. Allora facciamo così. C'è la barra, sì. Okay, so I'm gonna put this here. So, sorry about the inconvenience. And I think I also lost my speaker notes, so that's life. So I was saying that from Go 1.13, you get this version. There are no excuses to use that. Is more compact. That's basically the equivalent of this version, more or less. And then you have errors.s that is more or less equivalent to this version, the type assertion or the instance assertion. But, as I said, that is offering a bit more. So in the simplest case, they behave as the same thing, but in Go 1.13, you can have this full wrap of errors, and those two functions allow you to inspect if the error that you are looking for is inside the wrap. And you do that by basically using, I need this. You do this by either using these errors package that is not coming from the official library, or you do that by using the %w format in the errorf. And again, by doing this, you not only check if the error is of that particular type, of that particular instance, but you check into the wrap to see if the error, one of the errors inside the wrap is the error that you are looking for. Now, a bit of talking about pure functions. So pure functions have two properties. One is the fact that you can call them as many times as you want. Their behavior won't change given a fixed input, given a fixed state of the system. The other property is the fact that it doesn't have any side effects on the external world. So it doesn't change the input parameters, it doesn't change any global state. And why is this important? Have a look at these two versions. One is relying on some client that is consuming some external services, some external database, and by doing that, the behavior of that function is influenced by that external system. And what's the problem with that compared with the other version? The biggest problem is that this version is a bit harder to test. So you can do that, you can mock that client, you can mock the external system, but again, this version is clearer. It only has one purpose, which is finding the names of the nodes, whatever it does, but it's way easier to test. You can write Go tests and test it. The other point is about not changing the external world, not having side effects on the input parameters, for example. You find something like this, and this is supposed to do some check on the node, but the problem with this function is that it does also something else, and then you look at your bug report where the name of the node changed from empty string to something else, and you have to put a lot of printfs in order to understand what was the function, what was that liar that changed the node of the name of our node. So again, I think that this is one of the cases, and in general, you should strive for having pure functions where you can, because they help the readability. A better version could be, renaming the function may help a bit, but I think that the real way to fix this is to delegate the responsibility of that extra work to the client, to the calling site, because that part doesn't feel to belong there. So again, it's not always like that. You may have different situations, but you should strive to use pure functions when you can, because they help a lot. More or less along that topic, I want to make a note about environment variables. So in the world of pods and containers, it's so easy, so it comes with so low cost to add a new parameter as a new environment variable and to consume that in your code to affect the behavior of the program. But what is the problem with that? There are a few problems. The first one is the fact that at that point, your program configuration is scattered across all the code base. Deep down in some nested package, you have this environment variable that is affecting the behavior of your application. And the second one is that on the reader side, not touching this, on the reader side, yeah, that's it. When you consume that function, you don't have any idea of what is affecting the behavior of that function. So again, there are better ways to do this. One is to read all the environment variables in one single place and try to propagate your configuration to your functions through parameters. And now let's move on to another topic, which is function arguments. The first one I see, again, this is quite recurrent, and it's what I call the mysterious booleans. So you have two calls like this, and what the hell they are doing? Like true, false, true, true, and I see even worse than this. And it always starts with an innocent change where you have this setup function, and then somebody needs to have a toggle to enable a webhook, and then you need to enable the deployment, and then you need to reset the state. I totally invented this parameter, but that's the idea. So that's how you get to something like this, and this is adding friction. You need to enter into that function, check the fifth Boolean. What was that fifth Boolean? And I think that having something like this, which is relatively cheaper, makes our calling point easier to understand. Or use a structure. Using a blind structure also would help. Go doesn't have function overloading, and again, like you start with a constructor needing a constructor, you create a service, then you need to create a service with a backend. Then at some point you need an IP, and then you need a service with a backend and an IP, and that creates a lot of duplication, creates a lot of functions with different parameters. And I think a nicer way to do this is to use functional options, basically a collection of modifier functions that you call against the object that you are creating. And this is how it renders here. This is how it renders. So it's clear from the calling side what you are passing to the object, or you can even have these generator functions where you basically pass the parameter that you are applying to your object. And again, this reads much better, in my opinion. This comes from Dave Cheney. There is a very nice article from him on the topic. Methods that can be functions. This comes with, from the enthusiasm, from the inertia of somebody that opens a file with a single Go object inside of it and a lot of methods. And come on, it's all methods. I'm going to add a new method. But in this case, it's not really necessary. And when you look at it, you think, why is this a method? Why this is being called against C? Am I missing something? And this is, again, extra effort that can be reduced. So if a function is a function and is not a method, let's make it a function. Let's make it belong to a real package. Pointers. Pointers are a nice feature of Go that doesn't exist in many other languages and make people a bit confused. So, and they are also different from pointers in C, so it's like totally confusing. You look at these two functions, and what do you think is the difference between these two? So what do you know they are doing if you look at those? When I look at those, I think that the second one is doing something on the object, and the first one is not. So that should be our rule of thumb. There are, of course, there are exceptions. There are objects that you can't pass by value, or you can, but you will spend a bad weekend trying to understand why that bug happened. So in this case, leaving exceptions aside, you should use pointers when you want to modify the object and use values when you don't need to. Same for pointer receivers. Pointer receivers have another point, which is you should strive for consistency. Don't have receivers as pointers and receivers as objects. And if you are in doubt, use pointers because you may expect a method to be able to access the object that is pointed to. How about performance? So pointers are more efficient. Yes, they are in a way. So they are more efficient in a way because you are copying the single pointer compared to copying the whole object. But by doing that, you may have that object allocated on the heap. And so you may stress a bit more the garbage collector. So there is no real answer. And what we should do is to try, in my opinion, to optimize for readability and defer the instrumentation and removing bottlenecks later on in our development phase. This item, and I think I need to a bit. This item is one of my favorite. I don't agree with all the items in clean code, but this is one that I like. A good code base should read like a newspaper. So you have the high-level details on the top, and then you scroll the code and you find the details about the article in the bottom. And that translates to our code base. So my point is, when you open a file, when you open up a file belonging to a package, you should see what the package has to offer to the world, because those are the high-level concept of the packages, and they should be on the top. And then having the details down in the file when you scroll it. So I see this happening often. Basically, like the developer, the contributor opens the file at whatever position their IDE gave them, and take the function, and they throw it at the screen, and the functions is where it's ticked. Order matters, again, have our offering to the world on the top, and then having the details, the implementation, the stuff that is used by those high-level objects on the bottom. Split to files is another often underestimated feature of packages. So I see a lot of people having one big package containing everything. If you split the package, you will improve the navigability of the project. I expect the main file of a package to be named after the package itself, and then having different files with different purposes and having them named accordingly. It's nice because I don't see anything on this side and I don't know what's coming next. So it's a bit of surprise every time I click the arrow. Asynchronous functions. Go has this very and totally easy way to spin up Go routines and to communicate with them, and people tend to get that out of hand a bit. And having functions like these that communicate with the rest of the world through channels add a bit of friction, because you don't see the life cycle of the Go routine from outside. And testing this is doable, but requires a bit of infrastructure from outside in order to have a select on the two channels and things like that. So we should try and to have the functions synchronous and wrapping them in a Go routine on the client side. So again, this is a recurring. Delegate the asynchronousness to delegate something on the client side, because then it's clear, it's easier to understand. And also At that point, testing this is trivial. You just call it. You don't have to put channels, weight groups, whatever in your test. And this is basically another wiki entry saying what I just said. This is another nice one, functions that lie. You come across a function and see a call like this. What do you think this function does? Clears the node, exactly. But the developer found a very edgy corner case where if the name is do not clean, then don't do anything. The problem with this function is that, again, this function is lying to the reader. So then you have a behavior that is different from what you see, and you need to put energy. You need to understand why that bug happened. So this is bad, and one way to fix that is to add a comment specifying the behavior, but who reads the documentation. Plus, that doesn't change anything on the calling side. So a better way is, again, to defer the responsibility to the caller and to put that logic in the caller. What if I had to call this a million times across my code base? Then call it in a different way, put a filter function, whatever, but don't lie to the reader. Interfaces, or unnecessary interfaces. Sometimes I see this happening. So they come with a new type, they wrap an interface around it, and they use the interface even if there are no multiple implementations of that interface, if there are no functions accepting the interface just for the sake of it. And sometimes you can even spot what language they are coming from. So if you don't need an interface, just don't use it. If you want to hide the implementation from the external world, just use private fields. The opposite side of the coin is not using existing interfaces. So instead of using files, using a reader will make your function more elastic, because then you will be able to use it with files, with the standard input, and bonus point, again, you will be able to test it without having to create a file. And the same goes for writers. So again, instead of consuming a file, consume a writer, easier to test, easier to use it with the socket or with your standard output. Oh. I didn't expect this to come in so early. Wrapping up. There is no wrap-up. This was just a series of scattered suggestions that I think will make our code base a bit better. If there is something a recurring theme, I think that the recurring theme is to try to not think only about your implementation, but think also about the guy on the other side that is going to consume your code. But I'm a firm believer of the Pareto's principle. And Pareto's principle says that 20% of the effort will give you 80% of the result. So my idea is that this is a small set of tips that will improve the code base way more than the effort that you put in place to implement them. And also, I'm beaten by the Pareto's principle multiple times when I need to finish the last 20%. I underestimated that. So I want to finish with finishing the quote from Rob Pike. Simplicity is complicated, but the clarity is worth the fight. And with that, I have finished my talk.
Yeah. So a lot of useful tips. I knew some of them, definitely not all of them. I would have liked more. And in particular...
You can come and contribute to the MetaLB and you get some for free.
I can try. In particular, two kinds. One is, I think it was in a talk yesterday, about not embedding interfaces because, or rather, embedding interfaces only if you really need and you really want, because they expose methods and so on. And the other is something that happened in my personal projects, where, for example, the problem is that you accidentally publish not really methods, but something that you were not thinking about in the first place. Typical example is the equal operator. For example, if I have some complex data, that in my case was a wrapper for a reflect type and so on, and you don't want the users to compare them with the quality because it doesn't make sense. And I found some solutions that are not really very clean. Let's say they're hacks. So I would be interested also in some tips in that case, not only in making the code clear, but also making the code difficult to abuse or to use incorrectly.
Yeah, so I don't think there is a straight answer to that. So one thing that you can check against is if, or no. No, I was thinking about asserting against the interface, but that gives you the positive case where your type is implemented that interface, you know, the blind with the underscore type equal, but you can't check that your code is not implementing some interface. So, sorry, I don't have a straight answer to that. But I would say that if the user is abusing, like yesterday's problems was even worse because you were implementing an interface that was used and caused a bug. But if the client of your code is misusing your code, then it's a bit of their fault too. So it's
yeah. So I wanted to provide a hack that we use to do this, to make struct incomparable. Usually we declare an exported type, which is of type function, and we call it non-copyable or like non-comparable or things like that. So you create a function type that is called uncomparable, and you put it as a field in your struct. Functions in Go are non-comparable. You can leave that to nil. So, and the compiler is most of the time going to remove it because it sees that it's not used. But that makes your struct impossible to compare. So you just have a field in your struct that is of type function that is called, like the type is non-comparable. So you're explicitly stating that you don't want that to be compared. It's a hack though.
One of the challenges I had moving to Go was like how we deal with validated structs, because you spend time to validate something, and of course if it's exported fields, then someone can just like rip the whole floor out from under you, and so tempted to put in an interface to prevent that from occurring. But do you have any ideas on that? So
I'm not sure I understood the problem. So the problem is that you craft your type, you fill it with values, and then you validate then that, and you don't want that to be polluted by somebody else externally. Or
yeah, I mean, I work on a runtime, and so if something is changed later, it could completely crash everything.
yeah.
So like the temptation is to keep it internal type, or like keep an interface over it so that once you hit validate, like for sure it will remain that way. But I know that like a lot of times Go programmers have problems with interfaces, and so I was wondering if there's another way to, or any other thoughts on these like validation problem.
Not really that I can think of. So the problem, the nice thing with Go and the problem with Go is the fact that you are exporting your fields to the external world, so it's easier to come back and to change them under the hood without and we don't want to use getters and setters, so you can't always win.
Hi, thanks for the talk and for the useful tips. And actually, obviously the majority of them are left to the developer, so like naming functions and the actual implementation, but I would like to know if which are probably the most useful static checks that we can have, maybe for like fun length to reduce the length of the functions, or maybe reducing the cyclomatic complexity, and so that can help us.
I mean, I'm using all the linters. There is that nice Docker image with all the linters that you can apply to one code base. I saw some GitHub hooks that allow you to calculate the complexity, and they even talk about the cognitive load of the code base, but I don't know, I'm not a big fan of them. I think that's why we are really hitting really hard on code reviews, and like that's why we are being paid. So that's the additional value of having something more experienced in looking after your code and trying to understand if that can be made better.
Hello. So my question is about the line of sight. In my experience, sometimes the happy path is not always like straight, but sometimes when a condition verifies true, I return the correct value early so that I can exit the function and it's okay. Is that a good way to work to, like if you have a positive condition, you can return early, or you should in any case check for errors or for the unhappy path and structure the code in a different way?
I would say it depends, because it really depends on the function. If, like, normally I try, like when I see something like this, I stop and try to think if there is a way to invert it, because that's what normally you would expect to find in a Go code base. But that's not always the case. Sometimes, if the function is really long, wrapping into sub-functions helps in that regard, and you can still flip the behavior. Some other times you need to live with that. So, sorry, I don't have there is no silver bullet there, but.
If there are no other questions, I think we're finished. Thank you again.
Thanks.